Hey everyone, I'm Adil, and with my teammates Wesley and Swastik from 52, today we'll give our final presentation. Our topic is IMDb sentiment analysis with LSTMs for enhanced recommendation. So, talking about the motivation, the current challenges are that the current recommendation systems rely heavily on numerical ratings. They tend to miss critical emotional nuances in the audience provided feedbacks, and they also fail to capture the subjective aspects of movie experiences. Our objective is to develop an advanced sentiment analysis framework that gets a deeper understanding of the audience emotional engagement in a subjective manner. Talking about the data set, we sourced our data from Kaggle. There's an IMDb dataset with about 50,000 movie reviews for natural language processing or text analytics. It has a total of two columns, the reviews, which are the text data given by the users for a particular movie, and the sentiment, which can be either a positive flag or a negative flag. This is the data set that we have. You can see that we have the dataset review column and then the sentiment column, and we also have a team review column. Talking about the input and the outputs, we have reviews from users in the form of textual data. And we also have output from sentiment, which is a sentiment towards a movie, which can be either one of the two tags, a positive or a negative. Talking about our prior work and experience, all team members have been exposed to and understand the LSTM architecture and its working, which is the backbone of this project. However, this is the first time we are implementing it on such an application. Talking about textual pre-processing and cleaning, we aim to remove the URLs, HTML formattings, punctuation stop words via the regular expression library. And we also converted all the lower cases and replaced slang words with the full forms, example given. And we also lemmatized the text via the NLTK library. Now Wesley will take on.
So this is kind of a code snippet of just how we did some of the removals. This is an interesting graphic from the EDA showing the distribution of review links. Most reviews are around 500 characters, like a paragraph, something like that. There were no class imbalances that we had in our data set, so everything was 50-50, both positive and negative sentiment. We also created a word cloud to kind of visualize the words that we're seeing the most inside the sentiment reviews. So that's kind of what this is. For the baseline models, we did logistic regression, naive Bayes, SVM, XGBoost, and random forest, and it turned out the most simplest model, logistic regression, performed best on our dataset. And so getting into our main models, the LSTM model architecture, we would have an input text that uses an embedding layer followed by one or more stacked LSTM layers used to capture temporal dependencies. Then we have a fully connected output layer with sigmoid activation for binary sentiment classification. So that's what the LSTM looks like. For a train test split, for the first LSTM, we did 80-20, and we did accuracy, F1 score, precision, recall. We also did some hyperparameter tuning for using our validation performance. And we're evaluating LSTM and by LSTM versus the baselines and reporting the best model on the test set. So this was the data split for our LSTM models. For LSTM, did 80-20. By LSTM, we did 90-10, and their performance was very similar in that aspect. It was a little bit more than logistic regression, but not by a huge margin.
Coming to the vanilla LSTM model, which is the unidirectional model, basically it preserves the data information from the past only. And the hyperparameters that we used for this were the embedded dimensions, hidden dimensions, then layers and dropout, and layers being 3 and dropout being 0.3. Going to the results, please. So after running the LSTM model, we got the results as we can see. For the initial epochs, we got very less validation accuracy, and it suddenly got boosted to around 0.85 after some time. And same with the model loss. Initially, at initial epochs, it was around giving more model loss of 0.7. Then it came down to 0.3 to 0.4 around. Now coming to the bidirectional model, which basically preserves information from both the past and the future. So it has a bidirectional flag added, so it's set as true. And we have used the same hyperparameters for this. It's the same as the vanilla LSTM. And the results for this bidirectional LSTM show us that we get a very similar accuracy. Like from the beginning, we get accuracy of around 85 to 90%. So we got an average of 90%. So from the results, we can see that in initial model accuracy we can see that it starts from 85 and goes constant till 89. So we get average of validation accuracy of 90%. While for model loss, we can see it goes from 0.3 to 0.5. So it is very constant in that case in comparison to the vanilla LSTM. So it's a better model. Now we have the references. We use basically the IMDb dataset for the project, and these are the references. Thank you.